Hello and good morning everyone. Today inshallah this is our third lecture in third week. We will continue on the topic that we already started this week about elementary matrices and row operation. I would like to start once more from this matrix or this question in specific. He is asking you, how can I write a matrix A, 1, 2, 3, 4 as a product of elementary matrices? This is really a very important question. Once more, I will need to write the matrix A as a product of elementary matrices. So in this case, I will start as getting the inverse of this matrix. So it's going to be 1, 2, 3, and 4. That's the matrix that I am going to handle. And as you know, and as we talked previously, if I want to get the inverse of this matrix using row operations, I will write a unit matrix from the same dimension beside it. Am I right? Which is to the right of the equivalent side. So it's going to be 1, 0, 0, and 1. Okay, let me turn the lights on and I will get back to the slides shortly. Okay. Let's focus with this problem step by step. Okay, I have 1, 2, 3, and 4. This is the very unit matrix which is 1, 0, 0, 1. The first step, or what we understand from the row operations, that if we succeed using the row operations to transform this matrix to be a unit matrix, we will get the inverse beside it. So I will start the first thing to be sure that the pivot of the first row is equal to 1. Then I will use it to oblige this value to be a 0 value. How to do this? I will start with the following. The first step, I will go multiplying, getting R2 dash by multiplying the first row in -3 as you saw previously, and I will add it on R2. So that's the first step. Are you with me, Farid? So that's the first step. Let's do it. If I try to do this, what's going to happen? Let's see. The first row will stay as it is. So it's a 1, 2, 1, and 0. Then I will multiply the first row in -3 and add it on the second row. -3 plus 3, the result will be 0. -3 times 2 is going to be -6 plus 4, so it's going to come up to -2. -3 plus 0, so it's going to be -3. -3 times 0, 0 plus 1, it is equal to 1. Now I made the first move by multiplying the first row in a constant, then I add it on the second. Now I will start by adjusting the pivot of the second row. How to adjust the pivot of the second row? Ziyad should equal to +1. How to do it? Then I will have to move this matrix by getting a new R2. So R2 dash will equal to -1/2 times R2. So once we do this, the new matrix will be, as you will see, which is going to be 0, +1. Then I will have -3 over -2, then I will have -1/2. So I multiply the second row in -1/2. Actually, there is stronger of this number. So it's going to be a 0, 1, then I will have 3/2, which is 1.5, plus -1/2. The first row will remain as it is, 1, 2, 1, and 0. The last process, Ms. Nada, is to force the numbers above the pivot of the second row to be 0, because I'm getting the reduced echelon form. So I will multiply Mr. Farid, the first row, or I will change the first row. So R1 dash will equal to adding R1 to multiplying the -2 in row 2. So it's a -2 R2. Okay, let's do it. The second row will remain as it is, 0, 1, 3/2 minus 1/2. I will multiply the -2 and add it on
multiply. Negative 2 times 0 is going to be 0, plus 1 is 1. Negative 2 times 1, negative 2, plus 2, the result will be 0. Negative 2 times 3 over 2 is going to be negative 3. Negative 3 plus 1, so it's going to come up to negative 2. In a similar manner, I will multiply the second number, which is negative half, into negative 2, so it's going to be positive 1. That's the first element. Now, I have a new matrix, which represents the inverse of this, the given matrix. First of all, this is A minus 1. So if matrix A was 1, 2, 3, and 4, then A minus 1 is gonna be negative 2, positive 1, 3 over 2, and negative 1 over 2. If we are correct, then the multiplication of these two matrices will equal to unit matrix. Let's try it. Okay, Fatin? Let's multiply the first row, the first column. So it's going to be negative 2 plus 3. So the first number is positive 1. Multiplying the first row by the second column. So it's going to be 1 minus 1. So the result will be 0. Multiplying the second row by the first column. So it's going to be negative 6. Then plus 6, which is going to be 0. In a similar manner, multiplying the second row by the second column, it will give you positive 1, so it is already the inverse. Remark, we have E1, that's the first process. We have E2, second step. We have E3, third step. So we did reach our goal after how many steps we used? 3 steps. The first of them, multiplying the first in negative 3 and added on the last row. The second step is multiplying the second row in negative 1 over 2. The third step was multiplying the second row in negative 2 and adding the result on the first row. So 3 steps. تفضل. Yes, this is one of the methods to get the inverse of a 2 by 2 matrix. One of the methods is to use the empirical method. Is to evaluate first the determinant. Then, if it's not equal to 0, it's a non-singular matrix. Then I will replace the order of the elements of the principal diagonal, changing the signs of the secondary diagonal. Then multiplying, I have the inverse. But this method, we will have to use it in order to get the elementary matrices. Now I have E1, E2 second step, and the E3 third step. Let's write E1 as an elementary matrix. When we talk about elementary matrix, I want you to think of a unit matrix. So the first step states that we multiply the first row in negative 3 and add it on 1, 2. So I'm going to write that's E1, which equal to multiplying the first row. Okay, I will multiply the first row in negative 3 and I will add it on up to 0. Multiply the first row of a unit matrix in negative 3, which is going to be negative 3 only. And then add it on the second row. So the new second row is going to be negative 3, 1, 1, and 0. That's E1, which is responsible about multiplying. Please be careful about the color. Please. Just be careful about the color. Okay. E2. Farid, can you tell me about E2? How to do it? E2 states that we will multiply the second row in negative half. So it's very simple. That's the unit matrix. That's the second row. Just multiply the negative half. So it's going to be 1, 0, 0, and negative half. I'm writing Ganna. I'm writing the third elementary matrix. The third elementary matrix states that I will add to R1 negative 2 and R2. That's E3. Please. Okay. I want you to do it with me. I will multiply the second row in negative 2, then I will add it on the first row. What's it going to be? It's going to be 1, negative 2, 0, and 1. 1. Those are the 3 row operations, and these are the 3 elementary matrices corresponding to those row operations. Okay, I want to write them Miss Seda. To get the inverse, how it's going to be written? It's going to be written like this. This is the A matrix. First of all, first step, we multiply in E1. So it's going to be times E1. Then, after we did this step, after we multiply the first row in negative 3 and then the second row, we multiply the second row by negative half. So I will multiply all of this new matrix by E2. Now I'm here. The last step is to multiply the second row negative 2 and then to R1. And who's responsible about this, about the elementary matrices? The last one. So the order is correct. Once we multiply E3 by E2 by E1 in A, the result was a unit matrix. This is what you did in here. Although I explained this in the previous lecture, but I thought it would be better just to go through it because the point of elementary matrices, how they are formed, how they are put together, this is really a very important place and contains plenty of questions. Remark the order. This is A. That's first operation. Second operation, third operation. Which leads to that the first or those row or elementary matrices actually represent A minus 1. So if I want you to represent the inverse Fct of this matrix as an elementary matrices, once more, I want you to represent the inverse of this matrix as an elementary matrices. This is the result. This is the result. And it will be written like this. E1, which is 1, 0, negative 3, and 1, multiplied by E2, which is 1, 0, 0, and the negative half, multiplied by the last process, or the last one of them, E3, which is 1, negative 2, 0, and 1. This is how to represent the inverse as elementary matrices. But he didn't ask you about the inverse as an elementary matrices. He asked you to represent this matrix, the given A matrix, as a product of elementary matrices. How to do it? After we reached this step in the previous lecture, I told you that each elementary matrix is reversible. So I can invert or getting the inverse of each of the operations. How to do it? If I want to get the inverse of this operation, simply I will get R2 double dash, which is R2 dash plus 3R1. It's going to be the inverse of this process. If I want to get the inverse of this elementary matrix, it's very simple. What I have to do is to get R2 double dash, a new R, which is going to be negative 2 times R2. You multiply the negative half. So I want to reverse it. Multiply negative. Okay, in this guy, the last one, I will reverse it. How to reverse it? I will get R1 double dash, which is simply R1 dash plus 2 of R2. This is how to inverse the elementary matrices. Okay? But this is not all. At this step, E3 times E2 times A1, A. How to get A as a product of elementary matrices? Further, I will move all of these matrices to the other side. How to move something multiplied from the right hand side to the left hand side? By the inverse. So I'm going to get the inverse of these matrices into the other side. But remark, when you get the inverse, it's really very important, major thing. That's A matrix will equal to. When you do the inversion, the process will be reversed. So it's going to be E1 minus 1 times E2 minus 1 times E3 minus 1. Farid, Why this happened? Because all of us know that, I will write it here. All of us know that A times B to the power of -1 equal B minus 1 times A minus 1. Are you with me? This is one of the propositions of the inverse. واحد من أهم العلاقات بتاعت الانفرس اللي لو عندي تو ماتريسيز ضربتهم في بعض وبعدين جبت لهم الانفرس يا عمرو. هياها اعكس الاوردر واجيب الانفرسز. وهو ده اللي حصل هنا. E1 تايمز E2 تايمز E3. لما اعمل لهم انفرس لازم الاوردر بتاعهم ايه اللي يحصل له؟ يتغير. According to this is really major. Now I can write A. I will write it here because as you see it's a limited space. Okay? Just let me check on the camera. Yeah, we can. Okay, it's simply if I want to get the A matrix, remark. The A matrix is gonna equal to first of all E1. Where is E1? Here's E1. Reverse it. So it's gonna be simply 1, 0, positive 3, and 1. Instead of multiplying -3 or 1 and add it, I will multiply positive 3 and add. So that's the inverse of E1. Okay, E2, which means we multiply in -2. So the second matrix is gonna be, I will reverse this process. So I will get the inverse of this number. So it's gonna be, where is it also for? Oh, here we go. So it's going to be 1, 0, 0, and then -2. And then finally, I will get to E3. E3, I multiply the second row in -2 and add it on the first row. I will multiply in positive 2. So it's going to be 0, 1, 1, and 2. If you multiply these three matrices in each other, you will get your A matrix constant. This is how to do it. And this is really major. It's really very important. He targeted this issue in plenty of midterms previously. It's a complete question about this. Giving whatever. He's giving you matrix A, the matrix B, and then he will ask you about the row operations responsible about changing the matrix A into matrix B. Or vice versa. He will give you matrix B and he will ask you about the elementary matrices to regain matrix A. While A and B are inverses from each other. So it's exactly the same sequence. Remark, this is really a very important problem. As you can see, we started from the definition, we did the row operations, we translated the row operations into elementary matrices. Once you multiply, please be careful about the order. It's A times E1 times E2 times E3. The E1, E2, E3, and please be careful about what he's asking you about. If he asking you about the elementary matrices that's going to form the inverse, here they are, E3 times E2 times E1, those three matrices. If he asking you about the elementary matrices that's forming the general matrix, get the inverse of these steps, which means I will reverse the order and reverse the operations. Are you with me? Are you with me? This is very, very important. I will get back to the slides. Okay.
يعني equals هو الانفرس دي كلها في بعض هيبقى ده هو
those three matrices are the inverse.
ايوه ده هيبقى الرايت انسر بتاع الرايت انفرس
استنى اعيد ورا.
لو جالي سؤال رتب A equals ده ميكس E negative 1
E1 negative 1, E2 negative 1, E3 negative 1, and those are the matrices. Okay, he's not going to give you, just a second, he's not going to ask you about a written from the previous exams, about the written, okay, about the written solution. I hope he will ask you about written solutions. Because if the exam was written, there will be marks around all of this. But unfortunately, it's a multiple choice. So he will give you the question and then he will ask you which one of these statements is correct. So you will have to do it and he will ask you about it. Once more, Meta, are you with me? Okay, بصي
هنا how can I write the matrix A? How can I write the matrix A as a product of elementary matrices؟ بص تاني يا فريد اهو R2 داش سوري R2 minus 3 R1. عملت الستيب اللي بعدين R2 داش negative half R2. الستيب اللي بعده R1 minus 2 R2. وصلت للانفرس. Remark. This is E1, that's E2, that's E3. If I multiply, please be careful about the order. If I multiply A first times E1 times E2 times E3, I have the inverse. Here we go. E1 times A, that's the first operation. The result we will perform this process only, so it's multiplied by E2. The result of the three matrices, then I will do E3. This is why we write in this order. Okay, very good. If I want matrix A, it means I will move this left hand side to be on the right side. Once you are moving this side from left to right, you will get the inverse with scalar. Once I'm getting the inverse, I will rearrange, reverse the order, and get the inverses. So E1, you will start with it to the power of n4. E2 will remain the same, because we are talking about odd number of operations. E3 will be E3 to the power of -1. Then we reversed the operations as you can see. Each operation was reversed. This is by multiplying the first and -3 and adding. The inverse is multiplying the first and most of 3 and adding. That's multiplying the second row -half, then multiplying in -2, the second row. The third operation was multiplying the second row in -2 and adding to first row, then multiplying in 2 positive. Those are the elementary matrices of getting of matrix A. This is the equation. Okay, very good. Here in this slide, you are done. This slide is explained completely. He is telling you we make elementary row operations in A until we get IN, which is the identity matrix as yet. That's the same procedures that like what we did previously. So starting from this matrix, for example, if I want to get the inverse of this matrix or to know if it is invertible or not, I can easily في حاجة ماشي Are you with me? Sorry. If I want to get, first of all, Ziad, before we solve the previous problem, you asked me, there is another method where we get the determinant of a matrix. If the determinant is equal to 0, which this means that this matrix is not invertible. صح Mr. Fahmy? Okay. How to check using row operations if this matrix is invertible or not? How to check? Just to get the echelon form. Do you remember what's the echelon form?
Yes.
What's the echelon form? Trying to put your matrix into an upper triangular matrix. لذلك فريد بص أول حركة. رحت ماسك الماتريكس بتاعتنا which is 1 2 -1 0 2 0 1 2 0. I've tried to accept an effort just to make the pivot equal to 1 or whatever, but be sure that the elements beneath this positive 1 is equal to 0s using the row operations. So I'll multiply the first row -2 and add it on the second row. I will add the first row on the third row. I've succeeded in doing this. That's the final answer. That's the answer that we reached. Okay, what's the rank of this matrix? Do you remember the rank? What's the rank?
Number of rows.
Number of non-zero rows. So the number of non-zero rows is 3. And the dimension of this matrix is 3 by 3. Since the rank equal to the number of rows and columns, so it is invertible. I can get the inverse. Now, how to be sure that your matrix is invertible? We can do it by 2 things. Either getting the determinant of the matrix. If it's equal to 0, it's not invertible. Okay? If it's not equal to 0, it is invertible. So, if the determinant is equal to 0, you can't get the inverse. But if the determinant was not equal to 0,
it means you can get the inverse. That's a method. The second method, if you use row operations. How to use row operations? Try first to put it on either echelon form or reduced echelon form. If I put it on echelon form first, now I will know if it is invertible or not. So suppose Mr. Amr, in the exam, he will ask you, state which of the following statements is correct. And he will write to you, matrix A is invertible. How to be sure? I will take matrix A and I will try to put it on the echelon form. If it reached echelon form, so it is invertible. If it didn't reach echelon form, so it is not invertible. Are you with me?
Yeah.
Okay, so I already did some row operations and it is invertible. If I want to get the inverse of this matrix, I can. I will do it with you once more on a 3 by 3. How to get an inverse of this matrix. I will write it with you and I will go through it step by step. I will raise all of this and let's do it step by step together. Now I don't have to do the elementary row operation, although I can do it. The problem with the elementary matrices or the elementary row operations, the elementary matrices mainly, is that if I want to make elementary matrices, I will have to make each row operation with a separate matrix. Do you need what I'm saying? Then once more. If I want to do elementary matrices, each movement, in order to reach one goal, I will have to do it step by step. Okay? This is just only the length of using elementary matrices. Here I'm not going to use elementary matrices. I will use the row operations to reach the reduced echelon form. So let's do it together. Okay? Here is the matrix, which is 1, 2, negative 1, 0, 2, and 0, 1, 2, and 0. How to get the inverse? In order to get the inverse, I will write this matrix exactly, but with an equivalence line here. That's the equivalence line. Then I will write identity matrix from the same dimension. This is a 3 by 3, 3 rows and 3 columns. So I will write here or put here identity matrix 3 by 3, which is gonna be the scalar 1, 0, 0, 0, 1, and 0, 0, 0, and 1. Now I will try to get the inverse, the first step. To be sure that the level of the first row, the element 1, 1, this element is equal to positive 1. We are lucky, it is equal to positive 1. So I will start the first matrix. This is my first matrix. In order to write, or I will write the first row, I'm not going to change anything in it. So it's going to be 1, 0, positive 1, 1, 0, and 0. Then I will use it to force the rows below to start with zeros. So I will multiply this number in order to bring a 0 instead of 2 in the new matrix. I will multiply this positive number, this one, in the same number but with opposite sign. So I will multiply the first row in negative 2. Then I will add it on the second row. Let's do it together. Negative 2 plus 2, the result will be 0. Once more. Negative 2 times 0 plus 2 is going to be 2. Negative 2 plus 2, so it's going to be negative 2 plus 2, so it's going to be a 0. Continue. Multiplying the negative 2 and the adding to 0, so it's going to be negative 2. Negative 2 times 0 plus 1, it's 1. Negative 2 times 0 plus 0, it is 0. Now I change it, the second row. I'm going to change the third row. The third row starts with negative 1. So all I have to do is to add this row into that one. using multiplying a row in a number and adding it on any row. So I will add 1 plus negative 1, the result will be 0. 0 plus 0 is going to be positive 0. 1 plus 0 is going to be positive 1. Then 1 plus 0 is positive 1. 0 plus 0 is 0. 0 plus 1 is positive 1. Now I have changed it the last row. تفضل.
يعني اقول ان احنا نعمل كده.
Multiplying one of the rows of the number and adding it on another row. لما نضرب صف في رقم وبجمعه صفتين. اتفضل.
ما عملناش multiply.
لا عملت multiplying 1. وكده انا ضربت الصف ده كله في بوزيتيف 1 وجمعته على الرو ده. فيبقى 1 times 1 positive 1 plus negative 1 is 0. 1 times 0 0 plus 0 is 0. 1 times 1 positive 1 plus 0 is 1. 1 times 1 is positive 1 plus 0 is 1. 1 times 0 0 plus 0 is 0. 1 times 0 0 plus 1 is 1.
يا دكتور هو الاسود اللي فوق ده احنا اصلا جبناه منين؟
اهو معايا مش
لا اللي جنبها بقى.
انهي جنبها؟ 1 0
لا
1 1
فوق
0.
لا فوق
1 0 0
ال 1 0
دي قصدك على نفس دي؟ دي الستبس بتاع getting the inverse. When you are asked to get the inverse of a matrix, you write this matrix as you can see at this one, then you do an equivalence line. Then write a unit matrix from the same dimension. وده اللي عملته في الماتريكس اللي قبليها.
ايوه.
فده ده كان 3 by 3. لذلك لما حطيت identity matrix حطيتها كام بكام؟ 3 by 3. By the previous example, it was a 2 by 2. So I will choose the unit matrix to be 2 by 2. حد يقول the second step فيصل. How to do the second step? The second step is to change this positive 2 to be positive 1. شباب انتوا مش مركزين معايا ولا ماشيين معايا؟ قول يا عم.
احنا ازاي عرفنا ان احنا نستعمل هنا قانون الملتبلاي او قانون تاني؟ ازاي نفرق؟
مش فاهم تقول ايه؟
لسه عاملين هنا قانون الملتبلاي ما استعملناش قانون تاني، ازاي نفرق حل المساله؟
باللي انا عايزه، باللي انا عايز اوصل له. انت عايز توصل لايه؟ انا عايز اوصل لواحد تحتيه كام؟ زيروز. ازاي تقدر توصل له؟ بهاو ماني اوبريشنز؟ 3 operations. Switching rows, multiplying row by number, or multiplying row by number and adding it on another. يبقى انا بشوف انا عايز اعمل ايه وافكر في مين واختار. انا ممكن اختار الاوبشن خلاف سيدات خلاف فريق. تعال اعمل معايا السكند رو. انا عايز النمبر ده يبقى بكام؟ بوزيتيف 1. How to change this 2 to be positive 1. رأيك أعمل إيه؟ فكر في ال 3 operations. We can multiply the second row in half. مش أنت لو ضربت السكند رو ده كله في half هيبقى النتيجة إيه؟ هيبقى ده بزيرو وده ب1 وده بزيرو وده بنيجاتيف 1 وده بهاف وده بزيرو. وكده جبت ال1 اللي أنت عايزه. صح ولا إيه؟ Let's do it. So I will multiply the second row in half. Multiplying the second row in a half. خلي بالك ان ده لازم هتتقله مش بكيفك يعني. 0 1 0 بعدين نيجاتيف 1 بعدين 1 over 2 بعدين 0. حضرتك مستر عمر what are you seeking for? I'm seeking to have a 0 beneath this number and a 0 above it. بص على الماتريكس اللي فوق مظبوط؟ في 0 تحتيه و0 فوقيه. So all I have to do is to rewrite it 0 0 and 1 1 0 and 1. طبعا الريمينينج بيتكتب 1 0 0 1 0 and 1. تمام يا شباب؟ In this the reduced echelon form.
لا.
Why?
عشان في 1
عشان ده. صح؟ يبقى still remaining one step. ده مش reduced echelon form. reduced echelon form يا فيصل يبقى دي unit matrix. دي مش unit matrix. هي unit matrix but this number should equal to 0. How to force this number to be 0? Let's see that. I will multiply, exactly right. I will multiply the third row in negative 1 and add it on the first row. Yes? Okay, do it. So
row in -1 and added on the first row, let's see. The last row will remain the same. 0, 0, 1, 1, 0, 1. Then I will start multiplying as we said. We will multiply by -1 and add on the first row. Okay, -1 times 0 plus 1, it's going to be positive 1. -1 times 0 plus 0, it's 0. -1 plus 1, the result is 0. -1 plus 1, the result is 0. -0 plus 0 is 0. -1 plus 0 is -1. The second row will remain as it is. So it's going to be a 0, 1, 0, -1. This is half and 0. So the inverse here, a minus 1, should be 0, 0, -1, -1, half and 0, and 1, 0, 1. This is how you get the inverse for this matrix. يبقى أنا لما يطلب مني أجيب inverse, when I was asked to get an inverse, all I have to do is write the matrix. Then equivalence line. Then you choose a unit matrix from the same dimension. Then start your row operations, trying to change the main matrix to be unit. What will happen with the equivalence after the or to the right of the equivalence line will be the inverse of your matrix. Okay? أي مشاكل؟ طبعا remember بص كده يا فريد. From this matrix to that matrix, how many steps did I do? From this matrix to that matrix, how many steps did I do?
1,
Yeah, 2.
3.
Actually, from this matrix to that matrix, I did 2 steps at once. Multiplying the first row -2 and the adding of the second row. Multiplying the first row +1 and adding on the -1. So I did 2 steps together. 2 steps, it means 2 elementary matrices. E1 and E2. I can't do them together. You read what I'm saying? Okay. This is the only obstacle in elementary matrices. تاني الاليمنتري ماتريسيز كل حركه هعملها هعمل بيها ماتريكس. لكن الرو اوبريشنز if I was not asked about elementary matrices I can do more than one step at the same